We've learned, over the past 30, 40 years that planet Earth is a complex, self-regulating system where you have, the atmosphere, the ice sheets, the oceans, and the living biosphere all interacting together. And these interactions is what determines the state of the planet. And the planet has been in one very desirable state since we left the last ice age. We call this an interglacial. You may have remembering from school when you learned that is the Holocene. So the Holocene is the state of the planet that has enabled us to thrive and develop our modern societies as we know them today. The reason why, and this is the key scientific insight, the reason why the planet stays in this desired state is that the large biophysical systems on Earth, we know roughly 15 of these big tipping element systems, like the ice sheets, like the large rainforests, like the big overturning of heat that regulate the El Nino system and the big weather systems in the world. These big tipping element systems, they not only regulate the state of the planet, they have multiple states. They can be in a good state supporting us, but if they're pushed too far, they cross a tipping point and they fall over and start behaving against us instead of helping the planet to stay in a desired state. And that is what we call a tipping point. What determines a tipping point is that the feedbacks that hold the systems in the desired state, which for us means that they cool and dampen when we stress, for example, by burning fossil fuels, remains in that desired state. So for example, a rainforest, which absorbs carbon, remains in that state thanks to the fact that it self-generates its own rainfall. It's a kind of a self-regulating system which cools the planet by absorbing carbon. If you cut down too many trees, you warm it too much, it starts burning up, it starts drying out, it crosses a tipping point, and it stops this feedback of generating rainfall. It becomes a self-drying system. The feedback changes direction from cooling and moisturing to warming and drying, and then it becomes a savanna. So that's the tipping point, when the system is pushed over from one feedback to another feedback and it shifts completely its state.